Hi, I'm Benjamin, and we're here to talk about Brightly's experience building a new platform in a presentation we're calling Forging the Future, One Platform to Rule Them All. I'm Benjamin Issa. I'm a senior DevOps engineer at Brightly Software. I've been there for about 5 years, and most of my work with them has been in the public cloud and the container orchestration space.
And I'm Shane Rowley. I'm a senior architect with Red Hat Services, and I work in the transformation org, working on large strategic engagements, and I've been working with Ben and Brightly for the past 18 months.
And as I said, we're here representing Brightly Software. And Brightly is an enterprise asset management software as a service company. We have over 20 years of experience supporting clients in the public sector, in education, in healthcare, in all kinds of different places. And when I say we are a software as a service company and we have 20 years of experience, I don't mean that we have 20 years of experience in the space. I mean, we have been offering software as a service since 1999, which is always a little crazy to me. I think about when I was in elementary school and the vision it must have taken the people who started the company to do that. But in 1999, we released our first product called School Dude, which was really successful. Clients loved it. You may have even heard that term. And it was transformative in the space, as you can imagine, particularly at the time. And so over time, Brightly grew pretty quickly, both organically and by acquiring products that supplemented its portfolio and the offering it gave to its customers. One issue with this kind of path, though, and the story of these acquisitions has been the technical fragmentation that comes with acquiring a lot of different products. And this is a not uncommon story. You might have heard that in some of your organizations as well. The operations team in particular had to spend time making sure that all these products were properly supported and that, that they all had, the development teams had what they needed. And product A, if the operations team provided a particular piece of automation or wanted to update the process for secrets management or pipelines or continuous delivery in product A, product B wasn't necessarily able to benefit because of that technical fragmentation. And then about a year and a half ago, Brightly was acquired by Siemens and became Brightly, a Siemens company. And this was a really exciting time for the company. It's a really exciting time to be part of Brightly. And this opens up the opportunity for us to enter new verticals, new markets, to supplement and enable Siemens, particularly with their abilities at the edge and IoT. And it provides and opens a lot of opportunities for Brightly. But the question has become, and this conversation really started internally about a year and a half ago, just before the Siemens acquisition, how do we manage the technical fragmentation within our company? We have good products, great products that our customers love using. They all have a solid foundation, but their process is different. And that's causing friction between the development and operations organizations within Brightly. How do we make sure that all these teams have what we need? And so we made the decision about a year and a half ago that we were going to aim to create a unified technical platform. And not just an infrastructure platform, but a shared set of APIs that our different applications could use, and we could begin to unify the process and technical stack within Brightly. But as we quickly learned, one does not simply build a new platform. And this was really where Red Hat Consulting came in and helped us kind of map out what we wanted to solve within our organization. Think of Elliot Goldratt's The Goal, right? Any improvement made outside the constraint is an illusion. So before we started building our new platform, we really wanted to step back and understand what are the constraints within our organization, right? What's keeping us from delivering software with the technical fragmentation? And one of these practices we went through, this was the one that stood out most to me as we mapped out our business processes, was the time it would take for a developer to put a new containerized service into production. We found that the average developer, if they had a new service they wanted to introduce, would have about 2 weeks of lead time before they could put something into production, just lead time, assuming all the development happens instantaneously. And so this was the problem when we stepped back and said we're building a new technical platform. This was the problem we knew we wanted to address. We wanted to eliminate the lead time for developers to introduce changes into production. And this was particularly big for us because at the outset, we didn't want the growth of this unified technical platform to be inorganic. In other words, we didn't want our technical leadership to say, you must use this platform, and that's why developers were forced to use it. We wanted everyone to be excited about and look forward to the opportunity to develop on this technical platform. So at Brightly, we established a team. It was a cross-functional team with people from with a heavy background in infrastructure to developers, and we call ourselves the Fellowship of the Pod. And after quite a bit of back and forth, we settled on this as our team motto, which was enabling rapid delivery by providing highly automated, and then the two important pieces for this conversation, automated self-service infrastructure. So we want to provide highly standardized, automated self-service infrastructure. The issue we had early on, though, was that we wanted to make sure this standardized self-service process we created for developers was accessible to them and easy, right? We don't want our developers to have to learn Terraform or CloudFormation. We don't want them to have to learn a particular new IAC tool, nor do we want them to have to think about subnets or network access control lists, things that developers don't really want to think about. We wanted to give them control over their own destiny to be able to provision the infrastructure they needed without having to think about all the underlying complexity. So our solution to this process, after going back and forth quite a bit, was to use the Kubernetes API for the vast majority of our infrastructure provisioning. And we do this by taking advantage of the operator model and open source tools that provision infrastructure using the Kubernetes API. So for example, we use the Red Hat Community of Practice operator to make changes and create new roles in HashiCorp Vault, which is our secrets engine. We use Red Hat AMQ streams to manage Kafka topics and Kafka users. And all these tools have been able to, with all these tools, we've been able to write automation that gives developers access to common infrastructure they need without them having to learn Terraform, without them having to learn CloudFormation. And they can do it, in most cases, in the same manifest files where they define their deployment or HPA or their service. So here's an example of how this would work. In our application clusters, we have sandbox clusters where we can all play around and break things. But in our application clusters, we centralize creation of namespaces to a particular repository. And in that repository, all our developers have access to submit pull requests, and our team approves them typically within 30 minutes to an hour. And that's the only human step. And for really common use cases where particular infrastructure is required, we have created a set of labels that a developer can add to their namespace that provisions infrastructure for them. So for example, up here you see that first label specifies that this is a development-controlled namespace, not a system one or something we're building. So we use the Kyverno to create a cluster policy that creates a role binding that gives them access to their namespace consistent with our internal security policy, and certain resource limits just to make sure there's no adverse effect to the rest of the cluster. Because the bottom two labels specify that Vault access is required, we use the Red Hat Community of Practice Vault operator to create a new role inside the Kubernetes auth method in Vault so that the service account in this namespace can assume a role and access static secrets at a given path in a key value secrets engine in Vault. And we use the same process for other things too. We use cross-plane and upbound to provision AWS RDS instances. And it's not just these really common use cases that we've been able to use this pattern. We've used this for a variety of different pieces of automation that our developers may need. So for example, our monitoring vendor is Datadog, and they have an operator we can use, and so we allow our developers to define their own alarms that get sent to them via PagerDuty using the custom resource the Datadog operator exposes. We allow them to provision Kafka topics using AMQ streams from Red Hat using a very similar process to the namespace we talked about. And so all these processes have been really successful for at least us in unblocking our developers, because now there's no separate pipeline, there's no separate ticket, there's no separate tool you have to use to provision the infrastructure you need, particularly in the most common use cases. Instead, you can add an annotation or a label to your namespace or create a custom resource using the same YAML manifest files you're already using to define how your application is going to get deployed and scale within OpenShift. And this has really been a valuable additional layer of abstraction for us within Brightly. So you think about kind of the most common layer of abstraction in the cloud is the services. We're an AWS shop, at whatever cloud provider you're using. For us, it's AWS. We don't have to think about the cooling or electric connections or terminating Ethernet cables. I've had a job where I terminated Ethernet cables. I'm so grateful people do that and that it is not me. On top of that, for us, you have the services that are built on top of the compute these public clouds provide. So for us, that's ROSA, Red Hat OpenShift on AWS. And then what we've been able to do by funneling all this automation through the Kubernetes API using the operator model is still using ROSA without needing a third-party component or a separate pipeline just for the infrastructure. We've created within the Kubernetes API an additional layer of abstraction for the Brightly platform that developers can use to provision the most common infrastructure they need. And this makes tools like Argo CD, like Tecton, this makes these tools that much more powerful, because now when your Argo CD application is synced, it's not just the pods or the service or the deployment that's getting created, it's also the underlying infrastructure that that service needs to begin moving right away. And it removes just one more dependency the developers would normally have on us. But one consequence that we found of creating a really highly automated platform that allows developers to provision this kind of stuff automatically is that developers are really creative and they will find a way to use the automation you've exposed to them in new, unexpected ways that make both your life and their lives easier.
So when it came to building Brightly platform, Ben's team, Fellowship of the Pod, they did a superb job building the foundational building blocks, all through automation, using the Kubernetes API to provision everything. However, onboarding the teams, we realized we needed something more. So we took the Brightly platform and evolved it even further. And that's where we built out an internal developer platform with the team that they like to call developer services. So when we think about developer experience, what does that really entail? So if we break this down, you might have heard the terminology inner loop and outer loop. Inner loop really essentially involves the localized developer experience. So we're talking about developers writing code, testing, debugging on their laptops. And it's really crucial that this has the fastest feedback loop as possible, because if you think about a developer wants to write a feature, if it takes hours or a day to be able to test and debug that feature, that just builds out the lead time even further to release into production. So we're looking for something on the order of magnitude of seconds to a minute tops if they want to be able to test something. On the right here, we have the outer loop, and we can think about this traditionally as the CI/CD pipelines, and this is where we want to integrate the application, the feature changes, build, publish, test it, and promote it to production. And there's other features that we consider as part of the outer loop too that I'm going to walk into. So digging a little bit deeper into the inner loop and what we've done at Brightly, part of this is the rapid scaffolding for the applications on the developer's laptop. So part of the tooling that we've used with this is Podman Desktop. So we can use that to provision containers quickly, any of the dependencies that the application has with database or et cetera. Developers are able to do that very quickly. As well, they're using Quarkus as a runtime, they're able to use test containers so that they can bootstrap their test dependencies as part of their application. In terms of testability, this is a critical piece for applications and a fast feedback cycle. So dependency mocking is a critical piece here. And our applications are using gRPC. And so we are actually able to find this tool, gRPC WireMock, that extends WireMock to be able to mock out gRPC endpoints for the applications. And that helped developers to eliminate the dependencies with external teams. And then also with gRPC, we get things like protobus for API contracts that help to create clear boundaries for the teams. Another piece I want to emphasize here with testing, you can see testing is a critical piece to fast feedback loops for local development, is this testing pyramid. And we think about the testing pyramid as the number of tests that we want to write in priority. So at the bottom of the pyramid, we have unit testing, which is the cheapest form of testing that we can write and execute. And this is really critical for the developers to be successful in getting that fast feedback. And then we have levels of component testing on top of that, and then building out narrow levels of integration testing so that they can test quickly their application with direct dependencies with that app's database, if it needs to integrate with a Kafka topic, for example. And then on the other end of the spectrum, we tend to think about things like end-to-end testing, which are really expensive. That's not something that a developer can easily write, and that's why that is small at the top of the pyramid, because they're hard to write those tests, they're hard to execute. So we really focus towards the bottom of the pyramid in terms of volume of the types of testing that we're doing. And so this helps for that fast feedback cycle. For the outer loop DevX, really we built this around Backstage. And has anybody used Backstage before? Can I get a show of hands? A couple people? This is a really great tool that is a foundational building block to building out full developer experiences. And so we use this as the baseline, and I'm going to show some examples of it. As part of this, we've built golden path applications. I believe this is part of the Spotify model. We have golden paths for pipelines and different types of applications on runtimes that are essentially reference architectures showing the applications in a working environment that developers are able to see, interact with, et cetera. Also, as part of the outer loop DevX experience, is we have fully built out pipelines for various runtimes using OpenShift pipelines, which is Tecton, which is Kubernetes native pipelines, if you're not familiar. And then also OpenShift GitOps, which is Argo CD used to roll out configuration changes on OpenShift. With these features, we're able to get some really cool features, such as service mesh enrollment for your application. You can toggle that with a simple flag. And then with the service mesh, you get some really cool things. I mentioned before that the applications are all gRPC applications, but some of the consumers need REST capabilities. So we enable that out of the box with gRPC to REST encoding within the service mesh. The applications don't need to code or configure anything. It's just a feature flag toggle within the developer experience. Also, they get token validation so that they get authentication and coarse-grained authorization out of the box for the app. They don't have to code anything. It comes built in with their service mesh enablement. And then some of the other feature toggles that they have are code quality. So they can enable code quality with Sonar Cloud very easily and get reports and coverage around that. And then with the testing aspects, they get features such as integration testing easily with patterns and performance testing that's enabled with reports. And then also with integration, we're using Debezium with a transaction outbox pattern for reliability of publishing messages. They get that pattern out of the box with their application, so they don't have to worry about configuring it themselves. And then on the production side of that, we think about observability. And with this, they get their Datadog dashboards out of the box configured for their app. And with this, they get the 4 golden signals, which I'm going to talk about in a little bit. So here's some examples of the IDP catalog. And this is Backstage, which is essentially that framework or tool that you can use to customize and build out that experience. And with this, they've built out this catalog to scaffold and enable new services for an app dev team, and other things such as integrations like creating Kafka topics. And so really, if you're a new app dev team, you want to build a new service, this is where you go, and you go and pick the runtime that you want or the integration that you want, and it's able to create and scaffold that for you. So here's an example of the template for creating the new application component. And here, you do things like pick the application name, the type of runtime you want. We have supported runtimes for Quarkus, .NET, Node. So whatever your team's choosing is, it's easy to implement that. Also, this is where you can do things such as your feature flag toggles that you want, and really gives you the option to create things quickly. And the other piece of this is that it scaffolds all of your, everything you need for your application to go from 0 to production very quickly. So it builds out your application, all the application configurations for your levels of environments all the way through to production, and all the configs that it needs to support that. And it's able to promote it through with a straight through CI/CD pipeline instantly. So developers are able to get up and started within a matter of minutes to deploy their application, and then they get to focus on writing their feature code. Here is another example. We have service dashboards. So when you think about the service is already up and running, there's a lot of information that people need to be able to access and see, and this really aggregates that for them. So part of that, they get access to the GitHub repositories that are supporting this application, any technical documentation. You can see we have a plugin for the Sonar code quality, so you can see an overview of code quality reports, as well as relations to other dependencies of this application. So you get a lot of high-level details here that anybody working with that application or anybody that wants to integrate or consume it is able to easily see. Also, we have the CI/CD pipelines integrated directly into Backstage. So as part of this whole view, you're able to see the success of those pipelines, whether your application's being promoted, if it's failing. And so you don't have to jump between tools. This is all built into the same tool that makes it easy to reference. So anybody that's familiar with OpenShift pipelines, this view might look familiar. This is a plugin baked in directly into Backstage that pulls out that view so you can see it here. Another cool thing, so I mentioned before the gRPC to REST transcoding. So that comes out of the box for developers. They don't even have to think about it. And the other cool piece of it is that they get OpenAPI documentation generated as part of their build process. And those APIs are documented directly into Backstage. So if you have a consumer that wants to call the APIs of your app, they can go look in Backstage and see what those APIs are. And again, this is all part of the whole experience to digest your app. And I mentioned before the 4 golden signals dashboard. So these are the Datadog dashboards that are generated for your application. And we have the 4 golden signals being saturation, latency, errors, and traffic, which are really the critical technical metrics that you want to measure for reliability for your application. Developers, they don't have to think about this. They don't need to understand it from a low level. This is to help them onboard quickly and help them support their applications in production. So you can see a lot of this tooling, it's here to help support the developers, help them to get onboarded quickly and be successful with their application. And they get to focus on developing the features which are critical for their business to be successful. The team that we built as part of this, they initially started as an enabling team from Team Topologies. So this was going to be a short-lived team that was there to support a number of app dev teams. But at some point, we were able to get the buy-in to build this as a long-running team. And this is more of a platform team now from Team Topologies that's supporting broad business capabilities. And one of the things we wanted to do to help this team be successful is build out the team charter. And this is essentially how they engage and interact with teams across the organization. So first, we have a consulting role. So if there's a new pattern that teams want to adopt or implement, the dev services team, they take on this consulting role for that number of teams. And essentially what they're doing is they're helping to guide that team to best practices within Brightly so that they can be successful, and allowing that team to really experiment and build out new patterns on their own. Beyond that, if more teams want to adopt this, then the dev services team actually takes this and prioritizes it in their backlogs and helps to pattern it out so that other teams can use it as a standard pattern within the org. And then beyond this, we really think about, Ben had mentioned earlier that Brightly was acquired by Siemens last year, and Siemens is really looking to leverage Brightly's software as a service capabilities. And as part of that is this dev service capabilities. And the scaling is, how do they scale out these patterns so that Siemens as well as Brightly can adopt these patterns so their teams can be effective. And so that's more how to pattern this, how to have broad organizational impacts and to consider for those teams.
And all this has kind of led us to a point where that friction between the operations team and the technical fragmentation of each of the products is largely resolved. Because now there are highly standardized sets of infrastructure that developers can provision automatically and in a self-service fashion, we can create clear ownership boundaries, which means teams can control their own destiny by provisioning automatically the infrastructure they need. They don't have to think about the complexity that is sometimes associated with the teams do their own DevOps model. They don't have to think about the firewall or network ACLs or anything like that. And the operations team knows exactly what they're responsible for in maintaining that automation and making sure that the underlying infrastructure is secure and safe and highly available. And this is all really possible. I just want to give a final plug for kind of the operator model inside Kubernetes. When I think about what distinguishes this effort from other efforts we've done at Brightly, is that we trust the Kubernetes API more to manage resources outside of just pods. And that makes the tools that Shane talked about, tools like Backstage, tools like a golden pipeline Helm chart, so much more powerful, because now it's not just deploying your pods, it's deploying all the dependencies that your service would need to run and get started right away.
Yeah, and I just want to plug in here, some of the backstory with this RACI is that we pulled the teams together, Ben's team, Fellowship of the Pod, the dev services team, dev teams that are going to be consuming all of this, and help them understand what is their responsibilities and relationships to each other. And when I think about this, what makes this successful is the teams are they're adopting a customer mindset. So DevOps as a term, it's shifting a lot to this platform engineering or platform operating model terminology. Really what I see that as is it's DevOps with the focus on the customer mindset, which is what DevOps always was to begin with. And Ben's team's done a superb job with that, thinking about the developers as customers and then extending that with dev services too. So how do we give them the best experience possible so that they can deliver what they need for their customers? And so just like Frodo sailing off into the sunset with the elves, you can sail off to success too by following the same patterns here, adopting the open source technology, customer success, and building your relationships with your customers and teams. Thank you.